So supersonic flow over a diamond airfoil. So at last we will get this type of contours: pressure, Mach number, temperature, density contours. You can get it. Additionally, you can find CLCD also. So for today's exercise, I'm going to take this model. So chord of 1000 mm, or if you want, we can reduce this to 100 mm also. And here thickness is 50 mm and half edge angle. Okay, angle between. So this is the chord line. Okay, angle between chord line and this one face is half edge angle 2 degree. So this is at 0 degree angle of attack. Okay, but better I will take it to some other angle so that you will understand how to do the blocking for this inclined models. So in addition to the half edge angle 2 degree, I am giving some angle of attack also. Always angle of attack has to be measured between chord line and the free stream flow direction. Okay, so angle of attack 5 degree. So this also I'm going to take a rectangular domain. So we will take 20 times everywhere spacing. Okay, I will take 20 times everywhere the inclined model. Then I will do the blocking. So here I have taken 1, 2, 3, 4, 5, 6. But if you want, here also you can split it. Okay, for example 7, 8. Here also if you split, it's up to us. So I am thinking to explain this time both structured, unstructured, inflation, sphere of influence, everything, so that it will be useful for your project or even your major project research, etc. So okay, so first I'll start with the structured mesh only. So like this, finally we will produce it fine near the airfoil. Yeah, so you can do the simulation for 0 degree angle of attack. This alpha less than theta. For example, assume theta is 10 degree everywhere, and alpha I'm varying from 5 degree, 10 degree, 15 degree. So these cases already you might have studied in the aerodynamics too. Okay, so I taught it for A section. So do you understand that is depends upon the alpha theta variation, you'll get different shock pattern. Do you remember this, or should I explain it once again? Because for this exercise, you should know what type of wave you are getting. Then only you'll understand whether your simulation giving the proper result or not. Okay, simply you'll get some color contours. You should know which wave will come in the corners. With that only first step you can find whether your simulation is correct or wrong. So okay, let me explain some short about this waves. So always, so here I have taken alpha less greater than or equal to 0 degree. Okay, it may be 0, okay, or some positive values. I haven't taken the negative value, so it is 0 or some positive values I have taken. So in that 3 cases, less than, equal to, greater than I have taken. So in all these cases, you can see in this bottom corner, always it is oblique, it is fixed. Okay, in this all the cases, always in the bottom corner it is oblique shock. Also in the mid corner, it is expansion fan. Okay, everywhere in the mid corner, it is expansion fan. This is fixed, it won't vary. Is this clear?
Yes, sir.
So whatever the case you are simulating, this one and these two corner, it is fixed. Only here oblique shock, here expansion, you will get it. Only this will vary, depends upon this alpha theta relation. That for that also I have one short form. So I have taken alpha less than theta equal to theta greater than theta. So you can remember this one, some short form. Okay, so first one is oblique shock, next one is no shock, next one is expansion fan. So if alpha is less than theta, then flow will be deflected into itself. So there is oblique shock. Okay, less than means oblique shock. If alpha is equal to theta, then free stream direction and this wall both are in the parallel direction, so there is no shock itself, just flow will pass through it, so there is no shock. Then if alpha is greater than theta, then you will get a wall deflected downward, empty space, so flow will get deflected, also accelerated, so also flow is turned away from itself, so we are getting expansion fan. So this is the short form, less than, equal to, greater than. You can remember this one, okay, oblique shock, no shock, expansion. From this, as a first step, you can verify your result. Is that clear?
Yes, sir.
Okay. So what I have taken is theta of 2 degree, alpha of 5 degree. So this last case. Okay. So this is fixed. Only here I will get expansion because alpha is greater than theta. So this condition finally I should get it. Okay. We will do first the designing. Chord length, then angle is 2 dB, then I will give symmetry, okay. So this is 100 mm chord, so 2 mm wedge angle at 0 degree. So let's try with 5 degree angle of attack, so I can rotate this. Just select, you can go to the operation toolbar, rotate. So about this center point, I don't want the duplicate, only final one is sufficient. So clockwise means minus 5 degree. Now this is my airfoil at 5 degree, is it clear?
Yes, sir.
Okay. So now I will go for the domain. So I should start with a new sketch, not in the same one. Just on rectangular profile. So I will take 20 times everywhere. Also I can give symmetry. These first two outer edges, then center axis, then you can give symmetry. Okay, now it is 20 times everywhere. So instead of symmetry, you can give 4000 here, but I have given symmetry. Okay, anything, anyway, you can proceed. So now I have to fill it. For that, you have to go to wireframe and surface design. So this surface sketch-based features, the third one from the last. So then I have to remove the material inside the airfoil. So for that, you should go to this operation toolbar, split. So this sheet I want to cut. Okay, select the sheet, that is the element to cut, and this line is my cutting element. Okay, so now it is removed. So this itself, if you are proceeding for the simulation, then you can go for the unstructured mesh. But if you are going for the structured, you should do blocking. So let me explain both. Maybe today I will explain structured, tomorrow I will explain without any blocking how to do the simulation and using unstructured. Okay. So then for the remaining blocking, every time you have to go to the new sketch. Okay, so I'm going to the new sketch. I'm drawing one vertical line. So that line should coincide with this trailing edge point. Now I can exit. I can do the split. So complete sheet with respect to this line, but I have to keep both sides. Now it is two separate portion. Then this side, so another one vertical line. Somewhere I'm drawing, and I can coincide with the leading edge. So now exit, do the split. So this sheet is the element to cut. This line is the cutting element. I have to keep all the sides. Okay. So this is separate. This is separate. This is separate. 4. Now here also I have to make the cut, horizontal cut. So go to the separate sketch. But this time I cannot draw it on this axis line. I should start from this the trailing edge point. But initially the picking is difficult. So simply somewhere near to that I'm selecting. I'm drawing as a straight line. Later I can do the coincide. Okay. Actually it is joined here, but for the visualization it is coming like there is a gap. You can check it when you're doing the split. For example, the exit, split this sheet into 2 using this line, keep both sides. Now you see it is 2 separate only. Okay. Then this side also you can do the same. Go to the new sketch. So I should not draw it on the axis line because leading edge point is somewhat tilted. If it is at 0 degree angle of attack, then it is fine. Okay. Okay, I made it as a 6 separate blocks. If you want, here also you can make the blocking. Okay. Maybe first I'll explain how to proceed with this. Maybe next time I will show with the blocking here also. Okay, from these 2 points. With this first we will proceed. How it comes, let's see. Okay, so now I can import the created geometry. So it is in the desktop, diamond Airfoil IGS. Then I have to do the naming, etc. So go to the edit geometry. So here itself we can create the geometry, but already you are familiar with the CATIA. So there itself we are creating and importing here. So first step in the design modeler and the mesh is this generate. Okay, both in design modeler and mesh generation, the both module first step should be clicking this generate. So the body is generated. We can see the orientation. Okay, it is coming vertical. So if you want, we can rotate this in the horizontal direction. So about x-axis minus 90 degree, if I rotate, it will be horizontal, right? So further go to create, body transformation, rotate. So this is the object I wanted to rotate. Then axis definition, instead of selection, go to the component. So about the x-axis, so all other axes should be 0, and angle will be minus 90 degree. Okay, now you see that light green color line. Okay, now it is rotated. Is it clear? Hello?
Yes, sir.
Yes,
Okay.
sir.
So additionally, I'm going to do another one operation, that is stitching all these faces. Because if you are going for more number of splitting, sometime if you import this to the FLUENT, what will happen? So each are separate sheets, right? So it will consider two edges here. Then for this also it will consider one edge. So in this line itself, it will consider two edges. Okay. So for this face, one edge. Then for this face, one edge, like that. Two edge will be taken. Then while doing the mesh, it will create some issues. So to avoid that, we can do the stitching of these faces. For that, you should go to the create body operation. This shoe. Okay. Select the body, apply, you can generate. So if it is not coming means, and everything is proper. Okay, it's showing the error. That means everything is already properly attached. If it is not attached, you will get this showing operation will be done. Is that clear? Hello.
Yes, sir.
Okay. So now already in each phases it is single line only it is taken. Sometime if you are going for more splits, so it will take two edges. So in that case you can go to the create body operation. There this stewing you can try. So this time it is not necessary. Okay. So now we can simply give the naming, and here also, so the edges, if you see, this is separate edge, this is separate edge. Okay, but in the top it is only one line. Okay, here it is only one line, but here it is two line. So if you want, you can go to the tool, you can go to the merge option, you can merge these two lines as a single line. Okay, generate. Now you see, if you select, it will be selected as a single line, so that I can give bias like a fine, coarse, fine, like that, because in the top it is only single line. Like that also, for your convenience, you can change it. But let's produce with these two edges itself. Let's see how the structure is proceeding. If you are facing issue, then we can convert this into a single. Otherwise, we should go for another one blocking. So we will try all the possibilities. Is it fine?
Yes, sir.
Okay. So I'm proceeding with the two edges only. So I name it as airfoil. Take all the edges and the print as inlet, like we have taken at the Supersonic airfoil. Outlet. Naming is over. I'll go to the machine. So here also first step is Okay, first step is generate mesh. So generate mesh. So you can see it is the unstructured, because here it is quadrilateral, here it is triangular. But what we need is everywhere quadrilateral. So we are going for first step was mapped face meshing. Okay, so that we will get quadrilateral cells everywhere. Now update, there won't be any triangular meshes. Okay, even it is like a triangle, you can see 4 edges. Here there is one small line. So now we will refine it. So let's start with all these vertical lines for the bias factors. So I will go to the sizing. So let me select all the vertical lines first. Okay, first this 4 I will take it. Let's see how it comes. So I'm going for the number of divisions. And here maybe 50 I'm taking. Okay, go to the hard. That means I'm forcing the system to follow whatever I'm giving. Then bias factor, it should be fine towards the airfoil. Okay, initially I'm giving some 200 simply. Now you can see these first 2 edges coming properly. Next 2 edges, it is in the reversed bias. Okay, so one option is there. Now itself you can remove these 2 lines. Separately you have to give the bias for this 2 line. Otherwise, in the bottom you can see reverse bias option. That you can select. Whichever the line you have to reverse, that alone you have to select it and apply. Now that is reversed. So with the with the one command itself, so whatever reversed, that we can select it in the bottom. Is it clear?
Yes, sir.
Okay. Similarly, the bottom one we will try. Actually, all 8 also you can select it in this sizing. Sometime if you take more number of lines, it will be confusing. So I am taking 4, 4. So I am going for number of divisions, 50, hard. I am selecting the first one itself, then bias factor of 200. Now only the second and fourth line, it is fine towards the airfoil. First and third one, I have to reverse it. So they select the bottom one, reverse bias, and press Control and select first and third one, apply. Now you see everything is in the proper direction. Okay, let's update and see. But these horizontal lines we haven't given, that also we have to give. Okay, you can see course in the bottom and fine towards the airfoil. Only the vertical portion we have given. Is it clear? Only the vertical alignment we have done. Now this horizontal alignment we have to do it. Any doubt?
No, sir.
Okay. So now I will select all the horizontal lines. Here also simply I'm taking 50. I'm just selecting the first one. And here I will give some 100. Let's see how it comes. So only this one, and this one comes properly. So these 3 I have to reverse. So press Control, select the edge, select these 3 edges, and apply. So that is also reversed now. Now update. It's showing some error. Okay, there is another one small line created here automatically. So software, what happened? It produces us the unstructured. Only the old software is the gambit. In the gambit, even you can create the structured mesh. Here you may have 5 splits, but in the above you may have only one line. Okay, here 5 edges, here only one edges. That will create the structured mesh. But in this new ANSYS workbench, if there are 2 edges, here one edge, then it will create the unstructured. And how to rectify this? Here I have 2 edges.
Merge.
Yes, we have to merge in the geometry. So go to tools, merge. So these two lines, apply, generate. Merge. Yes, pieces are not visible. So let me export it to the mesh. I don't know whether it is just visualization error or really that surfaces are gone. No, it is gone. Now it is there, right? I see it is not coming. So when I yesterday tried, I didn't face these issues. So everything is random only. Suddenly some line will come. Now it is coming. I haven't done. I just opened and closed the geometry. I generated again, but this time it is coming. Do you see? Now it is a single line. There is no two lines. Okay, it is a single line only. Then I have to do that from the beginning. lab file. Same steps I'm just repeating. Bias factor. This one should reverse. Update. So let's say this time we should get the structured mesh. Okay. Now it is correct, right?
Yes, sir.
Actually, while I was beginning, I couldn't find this mapped face meshing. Okay. What you will think, okay, something is wrong, you will close this, open it again. But instead, simply I just neglected it. I went for this edge sizing, then I could find this mapped face meshing. So all these glitches will be there. Okay, don't get confused, you just proceed. Sometimes if you are giving more lines, yeah, this is coming properly, right? Even though you are given properly, it will show some what is that? Distorted minus etc. and all. Okay, so don't think your missing is wrong. You can find where it goes wrong. Okay, only one line there may be a mistake that if you correct it, you can get the proper meshing. So in addition to the human mistakes, system also will create lot of disturbance, some temporary disturbance. Once it is updated, you may get it properly. Okay. Now I'll go for this airfoils. Let's see here, two edges in the top, only one edge. Whether if I'm getting properly or not. Otherwise, I have to merge these two lines also. Otherwise, I have to make the split here also. Let's see how it comes. These four edges. I'm giving number of division as maybe here also 50. And I'm trying to give a fine on both sides. Maybe just 20. Okay. Fine, coarse, fine, again coarse, fine. Why? Because here I will get shocks in the leading edge, in this mid corner, etc. and all, you will get the shocks. So there I'm refining it. Okay. So wherever I will get the shock, there I'm refining it. Actually, compared to the subsonic, the supersonic needs very fine meshes. Okay, the same y plus is applicable here also. You see for subsonic itself, it comes 10 power minus 5 something. If you further increase the velocity, it should be further less. So always to capture the shock etc. properly, we should create very fine meshes. So definitely total number of meshes in the supersonic, it will be very high compared to the subsonic analysis. But here just for the demo, I'm taking just less divisions. Now let me update how it comes. Let's see. Okay, software adjusted itself like fine, coarse, fine, like that. Software adjusted in this outer edge, and here it followed what I have given. So there is no issue. I can proceed. Here two edges, in the top one edge. Okay, if it is not coming, if it is coming like unstructured, then no other way. Two option is merging these two lines as a single line. Otherwise, creating the blocking from the center point. Is it clear? Hello. I will show that mesh also, that is split in the mid corner. That also I will show you. Already I created that. Okay, here it is not smooth, so you know how to adjust it. Instead of 100, simply I'm giving 500. See how it comes. System update ஆயிட்டு system update ஆயிட்டு கேடிஆர் சாஃப்ட்வேர் system update ஆயிடுச்சு கேடிஆர் டீச் பண்ணும்போது a little bit adjusted. Okay, you can further refine it. Instead of 500, you can give 700 something. It will be further closer to that. Okay, and Y plus also you know how to adjust it. So here instead of bias factor, you can go for this smooth transition. Okay, 1.2, 1.5. That if you adjust, you will get the very fine meshes. That you know that. Simply I'm proceeding with this only. So with that, shall we go for the simulation? This you understand, right?
Yes, sir.
Okay. So this I said for the normal system, you go for serial. If you are having a workstation with more number of cores, you can go for the parallel. Okay. So first let me check the axis. Go to the display, options, axis. So mine is aligned in the opposite direction, right? Now you see this is the positive angle of attack. Okay, from the right to left, I should consider the flow. Is that correct? Hello?
Yes, sir.
Okay. So scale, I don't change it. Here solver, it should be a density based. Okay, for subsonic itself, we can proceed with the density based, but it will take more iterations. So for the simplification, we are going for pressure based. But for the supersonic, definitely you should go for density based. And here there is no much flow separation, etc. Very slender body, low angle of attack. So I can go for the steady itself, because you can see that kinetic energy is very high in the subsonic airfoil. When the flow passes over this wall, so there is a loss of momentum. So the kinetic energy is decreasing. At last it is separating. But here the flow is supersonic. So almost the flow will be attached. The flow will leave the body smoothly if you take these slender bodies. So the steady itself will work here. Then energy should be on, because supersonic there will be a much changes in the temperature, etc. Then as it is the flow over the object, we are very much interested to find the viscous effect. So we know we can give a k omega SST model. Okay, so k omega SST means it will apply k omega near the wall, k epsilon in the free stream. Then material air, so it should be ideal gas, not constant. To predict the temperature changes, Sutherland equation, which is valid up to 2000 Kelvin. Then boundary condition, airfoil is wall, inlet. So if you know the velocity, you can find the corresponding velocity. I can give it as a velocity inlet. For example, Mach number 3 I wanted to give. Okay, assume that speed of sound is 340. Then what is the corresponding velocity? Mach number is 3, speed of sound is 340. What is the velocity? Hello?
So 1320.
1320. Okay, so if you know the velocity, you can give that, and direction, it is in the -1 direction. Oh, sorry. It is in the right to left, so -x direction. So like that, you can give velocity inlet, or If you want to enter the Mach number value directly, then you can go for another inlet type, that is pressure far field. So in this pressure far field, it allows the users to enter the Mach number directly. Okay, already we have taken the boundary condition very far to the object itself. So pressure far field you can try. Okay, atmospheric condition only, it is 0 only. So here I can give the Mach number directly 3. Is it clear? You can find corresponding velocity and give the velocity inlet. Or if you want to enter the Mach number, then you should go for the pressure far field option. Straight away you can enter the Mach number. Direction is -1. Anything you can give. Okay, well, let's try with pressure far field. Is it fine? An outlet, just it is leaving to the atmospheric condition. I'm not changing anything. Then reference from the inlet. Then I don't change it anything here. Okay. Then monitor, already mentioned this and all you can increase to 10 power -6 for the better accuracy. Then you can monitor the drag value on the airfoil. So drag is in X direction, then lift value, then Y plus value, everything you can monitor. Then initialize from the inlet. Okay, it is showing the velocity now, -1041. Initialize, run for some 10,000. So once I will get 10 power -4 in all the parameters, the solution will converge. Iteration will stop. But let me stop at some maybe 500, 600 something. Okay, it's converged because the mesh I have taken is very less. Okay, let's check the mesh count. See, I have taken just 20,000. Okay, quadrilateral cells. For airfoil 2D subsonic airfoil itself, I said it should be 1 to 2 lakhs. And this should be around 3 times, 4 times than the subsonic. That's why it converged very easily. So now we can get all the contours, pressure contour, Mach number contour, etc. You can see the wave pattern. Okay, so in the bottom it is, so okay, let me check with the Mach number. You can easily understand instead of pressure. Okay, for the Mach number, first you should select the velocity. Then in this velocity you can find the Mach number, display. You can see red color means maximum Mach number, blue color means less. Okay, it is decreasing in this order. So in the bottom we have the oblique shock. So Mach number is decreased from around 3 to 2.627. Okay, in the oblique shock, but in the top we are getting the expansion. So flow will accelerate. So from 3 to 3.15 approximately it is increased. Then in the mid corner again there will be an expansion fan. So this 3.16 further it is expanded to 3.3 or to 3.36. Similarly in the bottom also there is an expansion. So from 2.6 to 2.8 it is increased. Then there will be oblique shock in the top. So this 3.3 is decreased to 3 again. Okay, like that shock wave pattern you can understand here, whether yours is correct or wrong. Is it clear? Forces also. So first forces, then coefficient of forces. Okay, so this is your lift 0.012, this is your drag. It is in minus direction, so leave that negative. Is it? Simply will show the mesh alone. Okay, remaining step is the same. So I will show the mesh alone, then we can wind up. See, I made the 8 divisions. Okay, from this mid corner I should draw one line, then using split option I should split this small face into two. Okay, the line you should not write parallel to the axis. The line should be drawn to this mid corner of the airfoil. Okay, here you can see some color variation. If you go for a lot of splitting, sometimes there will be a error, like multiple edges will be there on the single line itself. So in that case, I went for this shoeing. Okay, now see, you can see the tick mark. That means that stitching operation is done here. Okay, if in all the lines everywhere, if it is only one line, if I try to do this shoeing operation, it will fail. Okay, red color mark will be there. Instead, if there are some two lines merging on the same line, then you can do this shoeing, so that we can combine two coincide line into a single line. That operation you can do. Additionally, sometime while splitting this same face itself, additionally another one face will be created. A lot of glitches are there. In that case, you can suppress, for example, this one, even that original face also sometime will happen. So that face alone you can suppress. You can see that happened yesterday. I was doing the splitting, even though if you take this is separate, this is separate, this is separate, everything happens separately. Additionally, I could see another one face, that is the original face without splitting. Then what I did, simply all those body you can find it in this part bodies. Okay, just right click and suppress, so that it will be removed from the analysis. Now if you proceed for this mesh generation, you won't face any issues. Here see, I have done the mesh. I don't face any issues because already I showed that is stitched everything, and I suppress the unwanted lines. Okay, I maintain the proper Y plus also here.